Hello everyone. This video is on section 8.4 part 2 titled Multiply Radical Expressions or Multiplying Roots. In this video I'm going to be going over a version of your Knewton Alta assignment for section 8.4 part 2. Please understand that the version that I see that I'm doing in this video may or may not be exactly the same version, right? May not be the same questions that you see when you do the assignment on your own. But the objectives will be the same, the questions will be similar, like they'll be asking you to do the same stuff, and the way you would go about doing them would be similar as well. So I'm hoping that watching me do this here helps you in some way when you're working on the assignment on your own. Alright, so here's your assignment page. You will not be seeing the words preview of. Right, this is my preview of it. You'll just see the title of the section, right, the title of the assignment, the mastery bar, right, telling you how far along you've gotten, and the objectives. Now it looks like there are 3 objectives in this particular assignment. And this question I'm going to be working on is on the objective, use special product formulas to multiply radical expressions. Really what I'm going to be doing is using polynomial multiplication to multiply. I'm going to basically doing I'm going to be doing multiplication like you multiply polynomials for all these questions. And then underneath every question you should be seeing a feedback button, which allows you to send feedback to Knewton. You will not see an instructor cheat button. It's for instructors only. But you will see a more instruction button, which I would highly recommend using if you're ever struggling with a question or an objective. Right, click on this button, and some extra reading material or videos or both will be provided to you, and you can hopefully use that to help you out with that particular objective. Alright, so what we're asked to do is, for every objective in this section, we're asked to basically multiply radical expressions. Multiply expressions that have a radical or a root in it. Alright, and as I said, it's going to be just like you were multiplying polynomials. Only you have to then simplify radicals when you're done and combine like radicals. Right, you'll see when we get through all these examples here. Alright, so I wrote this one out. Let's do it on some paper. Alright, so here we have the quantity 3 minus the square root of 6, this whole quantity squared. Now remember what this means. Remember, this entire expression is in parentheses under the exponent of 2. So that means this whole thing is getting squared. Not just the 3, not just the square root of 6, but the whole thing. Remember what it means to square something. That means you're taking 3 minus the square root of 6, right, the base, and multiplying it by itself. So this is 3 minus the square root of 6 times 3 minus the square root of 6. And then you multiply just as if you were multiplying polynomials. This has 2 terms, 3 and negative square root of 6. This factor also has 2 terms, 3 and negative square root of 6. How you multiply polynomials was you took every term from one factor, and distribute it to the other factor, right? When you multiplied 2 factors of 2 polynomial factors. Same thing here. Take the 3 from this first factor and distribute it to the other factor. So I'll have 3 times 3, which is 9, and then 3 times negative square root of 6 is just negative 3 root 6. That's it. Don't make it the square root of 18. this is not in a square root, this is not a radical, and this 6 here is in a square root, it is a radical. You can't multiply radicals with non-radicals. Right, so it would just simply be negative, because it's a positive times negative, negative 3 root 6. Okay, so now I'm done with the 3. And next I move over to the negative square root of 6 term and distribute that to the other factor as well. And then I'll combine like terms and simplify, and we'll be done. Well, negative square root of 6 times 3. Again, it's a radical times a non-radical. You can't put those together. You can't say that's the square root of 18. Don't do 3 times 6 there. This is just negative square root of 6 times 3, or negative 3 times the square root of 6. And that's it. All right. And then negative square root of 6 times negative square root of 6 would be positive square root of 36. Now these you can do. Remember the product rule for radicals. The product rule or product law. The square root of a times the square root of b is the square root of ab. Right, as long as a and b are both non-negative, right? But you can do that with two radicals, two square roots. Square root of 6 times square root of 6 is square root of 36, or square root of 6 squared. All right. So I multiply, just like polynomials. So I guess I should write that as my first step. Right? Actually multiply out like polynomials. Simplify any radicals that need simplifying. Now the square root of 6 is already as simplified as it gets. Right, there are no factors of 6 that are a perfect square. So these two radicals are already totally simplified. The square root of 36, however, is just 6. Right, so we end up here with a 9 minus 3 times the square root of 6 minus 3 times the square root of 6 plus, and then this radical here is just 6. The square root of 36 is just 6. And then the final step is combining like terms. Combine like terms, like radicals. So the constants go together, right? The non-radical terms, right? 9 and 6, those are non-radical terms. They don't have a root symbol. Well, 9 plus 6 is 15. And then the terms that have the like radicals, and you remember in section 8.4 part 1, they talked about how to add and subtract radical expressions, right? You get like radicals. Negative 3 root 6 and negative 3 root 6, they both have the square root of 6. These are like radicals here, right? So you can combine these, and if you have negative 3 of the square root of 6 and another negative 3 of the square root of 6, that's minus 6 of the square root of 6. You just combine the coefficients. Right, so it'll be minus 6 times the square root of 6. And that's it. Again, you don't combine these, because this has a radical, right, the 6 root 6, and this does not have a radical, 15. Right, just like multiplication, you can't multiply radicals and non-radicals. Same thing with addition and subtraction. You can't add and subtract radicals and non-radicals. So that's it. 15 minus 6 times the square root of 6. Now what I'm going to do next is something you can do at home as well. Let me check my answer. Alright. Well, I'm going to do it with a calculator. Alright, so I'm pulling a calculator up. And I'm first going to punch in the expression we started with. Right? We have this in parentheses. We have 3 minus the square root. Pardon me. 3 minus the square root of 6 in parentheses, and then that whole thing's squared. Right? Let's see what we get. So 0.3030615433 and so on. Right? Now I am going to enter the expression I ended up with at the very end. 15 minus 6 times the square root of 6. And we should get the same exact value if everything was done correctly. 15 minus 6 times the square root of 6. And look at that, right? They are the same value. Wonderful. Right, and that should always happen if you're doing things correctly, right? The value of the expression you started with should be exactly the same as the value you ended with. And this goes for expressions with variables as well, right? Just replace the variables with numbers and check, is the expression in the beginning that I started with the same value as the expression I have at the end? And that should be the case. Great, so it looks like this is good. Now let me enter this. Go back to the back to the assignment and enter this value. 15 minus 6 times the square root of 6. And that's all. Alright, then after every question, hooray. After every question, they do have answer explanations, whether you got the answer correct or incorrect. Please read through these. If you got it correct, read through it to make sure you got it right for the right reasons. Or maybe they'll show you an alternate way of doing it, like this one here. This is a different way than I did. They're using a formula for squaring a difference. Maybe they'll show you an alternate method that you like better and will use in future questions. Now, if you got it wrong, definitely read through the answer explanations, see where you went wrong, why you were wrong. Hopefully you can figure that out and learn from your mistakes and, do better on future questions. Alright, so next question. Now, as I said in the first question, I'm going to be doing what this says here. Use polynomial multiplication to multiply radical expressions. I did this in the first example. I'm going to do it with all of them, right? No matter what the objective is, because you'll see that no matter what the objective is here, you can multiply expressions with multiple terms the same way you would multiply polynomials all the time. Alright, so I'm going to write out this expression here. We have a product of, again, two radical expressions being multiplied together, and we're asked to write an exact answer in radical form, right, with the root symbols and everything. Alright, so I'm going to write this out and do it on some paper. Alright, so same deal here. We've got an expression with two terms, 5 times the cube root of x, and then plus 5, multiplied by another expression with two terms, the cube root of x and plus 1. So I'm going to start with, pick one expression as like a home base, and then I'm just going to distribute every term from one expression to the other, and then we'll combine like terms when we're done. So I'm going to start with this 5 times the cube root of x. So we have 5 times the cube root of x times the cube root of x again. Now the cube root of x times the cube root of x I can do, and then you have, the 5 is not in a radical, so that factor of 5 is going to stay outside. And then we have the cube root of x times cube root of x, that's the cube root of x squared, right, using the product rule. And that's as good as that's getting. Alright, then we have 5 cube root of x times 1, plus 5 times the cube root of x. Alright, so those are the terms I get after distributing the 5 cube root of x. And now I move over to the positive 5 and do the same. Distribute the positive 5 to the two terms in the other expression. Positive 5 times cube root of x is exactly that, positive 5 times cube root of x. There's plus, 5 cube root of x. And then positive 5 times positive 1 is positive 5. And then I combine like terms, like radicals. Well, the only terms that are like are these two. They both have the cube root of x. index, right? The same index and the same radicand. So these can be combined. This has the cube root of x squared, right? A totally different radicand than these two have, so I can't put these with these. So the only two terms I'm combining are these two middle ones. So we end up here with 5 times the cube root of x squared plus, and then putting these together, I have, 5 of something plus 5 of something is 10 of that thing. That's 10 times the cube root of x, and then plus 5. And that's it. I mean, that's as simple as that expression will get. There are no other like terms to combine. And once again, if you'd like to test it out, go ahead and replace x with some number, really any number you want here, because this is an odd root, right? You can take odd roots of anything. And see if the value of the original expression is the same as the value at the end. And I leave it to you to test that out if you wish. Just replace x with different numbers. Alright, so that's what I'm going to enter. First term was 5 times the cube root of x squared. And then we had, after that, plus 10 times the cube root of x. Move the arrow over, and then after that, plus 5. Alright, that was as simple as that would get. Okay, and please read through your answer explanations. Next question. So basically, it's pretty similar. It's still the same objective. Use polynomial multiplication to multiply radical expressions. I'm going to do the same thing. We're multiplying two radical expressions here. I'm going to take each term from one and distribute it to the other, and then combine like radicals at the end. Alright, so once again, I got two terms here in this expression, multiplied by another expression with two terms. I'll start with these over here. We'll take the 6 times the cube root of x and distribute it to the other expression. 6 times the cube root of x times the cube root of x again. That would be 6 times the cube root of x squared. Right? And just like the last example, cube root of x times cube root of x would be the cube root of x squared. Then we have, positive 6 times the cube root of x times 2 would be 12 times the cube root of x, right? Plus 12 times the cube root of x. Okay, now I'm done with this 6 cube root of x term distributing. Then we'll move to the next term in this, which is negative 6, and distribute that as well. Negative 6 times the cube root of x is exactly that, right? Minus 6 cube root of x. And then negative 6 times positive 2, negative 12. And then the only terms that are like here are these two in the middle. They're like radicals. Those go together. Cube root of x, cube root of x. This does not, because it has a different radicand, right? X squared instead of x, right? And then the other is not a radical at all, just minus 12. So we end up with 6 times the cube root of x squared. Then putting these together, 12 minus 6 is 6, so plus 6 times the cube root of x. And then you have the minus 12, and this is it. This is as simple as that's getting. None of those terms are getting combined. And once again, if you want to test it out, just go ahead and replace x with whatever number you want. See if the value of the original expression is the same as the value of the final expression. I'll leave it to you to do some values if you wish. Alright, but our final result here is 6 times the cube root of x squared plus 6 times the cube root of x and then minus 12. That should be good. Great. All right, moving on. So we're back to that objective about using special products. Once again, I'm not going to do a special formula. You can if you want, but I'm just going to remember what it means to square something. It just means multiply that base by itself. And then I'm going to do all the polynomial multiplication like I've been doing in every question. Okay, so again, what this means is that you're taking this expression, 12 plus 3 times the square root of 2, and multiplying it by itself, right? You're squaring it, multiplying it by itself twice here. So this is 12 plus 3 times the square root of 2 times 12 plus 3 times the square root of 2. First I'll take the 12 and distribute it to the other expression, right? Now 12 times 12, it's 144. And then 12 times 3 times the square root of 2 is 36 times the square root of 2. Alright. Then, done with the 12, move over to the 3 root 2. Alright, this 3 times the square root of 2 and distribute it. Now 3 times the square root of 2 times 12, well 12 times 3, you multiply the ones that are not radicals, right? You multiply radicals with radicals and non-radicals with non-radicals. So 3 times 12, those are the non-radicals, that's 36, and then there's no other radicals, right? You just have the square root of 2. So this next term is plus 36 times the square root of 2. And then finally, 3 times the square root of 2 times 3 times the square root of 2. Again, multiply the non-radicals, that'd be 9, times, and then multiply the radicals. Square root of 2 times square root of 2 is the square root of 4, which we can simplify easily. Alright, this is just 2. Right? The square root of 4 is just 2. So after simplifying all the radicals, we have 144 plus, and I'll show you right now. You got some like radicals in the middle here. 36 root 2 plus 36 times the square root of 2. They both have the square root of 2 in common. You can put them together. 36 plus 36 is 72. So that's 72 times the square root of 2. Plus, and then 9 times the square root of 4. That's just 9 times 2. That's 18. And now I have some like terms. These constants, these non-radical terms, can go together. 144 and 18. And 144 plus 18 is 162. So we have 162 plus 72 times the square root of 2. And once again, these do not go together at all. This is a radical term. This is not. Can't add radical terms with non-radical terms. So this is it. And like in the first example, I'll leave it to you though. Use a calculator. Check this out. See if the expression in the beginning is the same as the expression I have here in the end, and it should be. Alright, so I'm going to enter 162 plus 72 times the square root of 2. 162 plus and 72 times the square root of 2. That should be good. Great. And again, please read through your answer explanations. And once again, they're using a formula, but you don't have to. Alright, next question. And now it's just simply multiply radical expressions. Okay. So notice that both these expressions here have just a single term. So you're just using the product property here. Alright, you're just using the product property, and then of course you're being asked to simplify at the end, right? It says simplify, and you should know how to simplify radicals now, but I'm just using the product property here really. Alright, so here there's no distributing to do, because each of these expressions has just a single term, a single product. 2 times the fourth root of 8y squared times, and then negative 2 times the fourth root of 12y cubed. Right? There's no distributing to do here. So this is one big product. You can rearrange the factors. Now, as I've been saying, when you're multiplying radical terms, you multiply the non-radical factors, right? 2 times negative 2 is negative 4. And then you multiply the radical factors, right? With the fourth root. So negative 4 times the fourth root. Now 8, and then, use the product property. And that's the only reason they said y is positive here. Because if y were negative, you couldn't use the product property, right? This radicand 12y cubed would be a negative number, and this is an even root. Remember, even roots of negative numbers aren't real, and the product property can only be applied when you're talking about real numbers. So that's why they're having y is greater than 0 here. Also, too, so you don't have to use the absolute value symbols at the end, right? Because if y is already positive, there's no need for absolute value symbols. That's the only reason that this is being pointed out. So you don't have to worry about typing absolute values. Anyway, multiplying the radical factors with the fourth root of 96 y to the fifth. All right, this is great and everything, but we should now simplify the radical. And I'm assuming you know how to do this, right? We've seen how to simplify the radical before in previous videos, previous lessons. I'm taking the fourth root of 96y to the fifth, and I want to break it up to the product of a fourth root of fourth powers, perfect fourth powers, times the fourth root of non-fourth powers. Now you could factor this completely if you wish, but I'll tell you right now, I can see it. You don't have to, if you need to factor it down completely, be my guest. But 96 is 16 times 6, and 16 is 2 to the fourth. All right, that's a fourth power. 6 is 2 times 3. Those aren't fourth powers. That's why it's in this other radical. Then y to the fifth, that's not a power, that's a multiple of 4. But I can break that up to y to the fourth times y to the first. All right. And now I can do this, right? The fourth root of 16 is just 2, right? And the fourth root of y to the fourth is, again, technically you should be writing the absolute value of y, but they told us earlier, assume that y is positive. So I don't need the absolute value symbols, right? That's the only reason they're saying assume y is positive. And then we have times the fourth root of 6y. And this isn't the answer, because don't forget we have the negative 4 in front, right? This when we're all said and done here, this is negative 4 times, and then the fourth root of 96y to the fifth is this 2y times the fourth root of 6y. And negative 4 times 2y is negative 8y. All right, so when all's said and done, when all's completely simplified and multiplied and junk, this ends up being negative 8y, outside the radical, times the fourth root of 6y. And once again, because y is positive here, no need for the absolute value symbol around that y. All right, and again, if you want to test it out, go back and replace y with some positive number. Replace y with 1, with 2, with 5, whatever you want. And see if the value of the original expression, this product here, is the same as the value of the final expression. And it should be, if you're doing things correctly. Alright, so that's what I'm going to enter. I'm going to enter negative 8y times the fourth root of 6y. Make sure that 6y is underneath the radical there. And that should be good. Now again, see, they have you break it, they remind you, hey, you can factor the radicand completely to find perfect fourth powers a little more easily, but I already knew it was going to be 16y to the fourth and 6y, but again, please read through your answer explanations. Alright, next question. So multiplying radical expressions again. Now these are, once again, single term. No need to FOIL, no need to distribute here. Right? There's no addition or subtraction in either of these expressions. So it's just like the previous example, where I multiply the non-radical factors, then I multiply the radical factors, and simplify the radical at the end. So once again, no distributing. Right, we're just multiplying a bunch of factors here. Multiply the non-radical factors. Right, 5 times 3 is 15. Times the cube, then multiply the cube roots. Right, and using that product property. Cube root of 3x cubed times the cube root of 18x cubed. That'd be the cube root of 54x cubed. This is all great and everything, but we have to simplify the radical. Right. Now the cube root of 54x cubed. And we're going to break this up to the cube root of a cube, right, third powers, times the cube root of some non-cube. Right. Now 54 breaks up to 27 times 2. Right, 27 is 3 cubed, a perfect cube. 2 is not. Then, this would be x to the 6th, I'm sorry. X cubed times x cubed would be x to the 6th. 54x to the 6th. And x to the 6th is a perfect cube. You know, it's a power that's a multiple of 3. So this is all I have here. Now the cube root of 27 is just 3. And the cube root of x to the 6th would be x squared, right? X squared cubed would be x to the 6th. Use that power to a power rule. So this ends up being 3x squared times the cube root of 2. Right, and that's going to go here. Right? And then don't forget we have times 15. Right, so we have 15 times this. And 15 times 3 is 45. So we end up with 45x squared outside the radical times the cube root of 2, inside the radical. This is what they want. Right? And once again, if you want to test it out, replace x with any number you want. This is an odd root, right? Cube roots. You can take cube roots of positive or negative numbers and still be real. Replace x with any numbers you wish, and see is the value of the original expression the same as the value of this final expression here. But yeah, so we have 45x squared times the cube root of 2. Like that. Wonderful. And again, just read through the answer explanations, please. All right. Next question is that same objective again. Just multiplying single term radical expressions, right? No need for distributing. And you see even roots here, fourth roots, so they're just going to tell us, hey, the variable's not negative. Once again, so that way you can use the product property, that way you don't need absolute value symbols. All right, that's the reason we're doing this for even roots in these questions. All right, so same deal, no distributing, just bunch of big product here, bunch of factors. Multiply the non-radical factors, -1, right? If there's nothing there, there's a 1, right? -1 times 3 is -3. Times, and then you have the fourth root. And I can multiply these fourth roots together using the product property. And once again, we can do this because, b is not a negative number here. These are real. 6 times 8, 48. And then b cubed, b cubed, and b cubed would make b to the 6th. All right, then I'm simplifying this, right? The fourth root of 48, b to the 6th. I'm going to break it up to the product of, the fourth root of a fourth power times the fourth root of a non-fourth power. 48 is 16 times 3. 16 is 2 to the fourth. That's a fourth power, and 3 is not a fourth power. B to the 6th I can break up to b to the 4th. Right, there's a fourth power times b squared. And here we go. The fourth root of 16 is 2. The fourth root of b to the 4th would be the absolute value of b But once again, we're assuming b is not negative here, so I don't need absolute values around that right now. So this is 2b times the fourth root of 3b squared. All right, and then this, all right, this is going here, and just getting multiplied by negative 3, that'll make this negative 6b, right? Negative 3 times 2, so I end up with negative 6b times the fourth root of 3b squared. And this is what they want. Right? This is the final result. Pardon me. And once again, check it out. Replace b with any non-negative number. See if the original expression is the same as the final one, and they should be. Right, let's punch this in. So we have negative 6b times the fourth root of 3b squared. And make sure that 3b squared is all underneath the fourth root. Great. Alright, next question. Same objective again. Right, multiply radical expressions. So another single term radical times another single term radical. So no need for distributing. Just multiply the non-radical terms, and then then the radical the non-radical factors, and then the radical factors, and simplify. And also notice that they said assume any variables are greater than 0. Once again, that's because we have even roots here, and in order for the product rule to be used, you have to have real numbers, right? So they're saying, hey, z can't be negative. And also too, when you simplify, if z is already greater than 0, then there's no need for absolute value symbols when taking these even roots, these square roots. Pardon me. Alright, so here it is. So once again, no distributing necessary. There's no single term times a single term. Let's multiply the non-radical factors. Negative 2 times 3 is negative 6. Times, and then the square roots together. Square root of 7z cubed times the square root of 14z to the 8th would be the square root of 98, 7 times 14, z to the 11th. And off to the side, I'm going to simplify that, right? The square root of 98, z to the 11th. Now you can break down 98 to, 7 times 14, which is 2 times 7. So you see there are two factors of 7. All right, this is the square root of 49 times, the square root of 2. That's the square root of 98. And then z to the 11th, 11 is not a multiple of 2, but 10 is, right? We can break that up to z to the 10th times z for z to the 11th. And this square root here would be 7z to the 5th, and you don't need absolute values around z to the 5th because we're already told that z is positive. Right, z to the 5th squared would be z to the 10th, and 7 squared would be z to the 9th. So 7z to the 5th times the square root of 2z. Right, once again, this is going here, replacing the square root of 98z to the 11th. And this is being multiplied by negative 6, and negative 6 times 7 is negative 42, right? So at the very end, I end up with negative 42 z to the 5th times the square root of 2z. And this is what I'll be entering. Negative 42 z to the 5th. And times the square root of 2z. And then make sure that 2z is all underneath the root there. Great. So that objective where we just multiplied, two single term radical expressions, that objective seems to be done. Right, let's move on, and then the rest of it's just going to be that, using I'm gonna do the whole using polynomial, multiplying these the way you would polynomials, right? Multiplying expressions with multiple terms. All right, so here we have 11 minus 6 times the square root of 2, right? That quantity being squared, right? Being multiplied by itself. Alright, so like you've seen me do before, this just means take 11 minus 6 times the square root of 2 and multiply it by 11 minus 6 times the square root of 2 again. First I'll distribute the 11 to these two terms. So 11 times 11 is 121. 11 times negative 6 times the square root of 2, that'd be negative 66 times the square root of 2. Now I'm done with the 11, and I'll move over now to the negative 6 times the square root of 2 and distribute that. Negative 6 times the square root of 2 times 11 would be negative 66 times the square root of 2 again. And these are like terms, like radicals that I'll combine in a minute. And then negative 6 times the square root of 2 times negative 6 times the square root of 2 would be 36 times the square root of 4, positive 36 times the square root of 4. But, you know that this is 2, right? So that's 36 times 2 there. So this is just 72, that last term. And now I'll combine the like stuff, right? The non-radical terms, the constant terms, we have 121 plus 72. That's 193. Right? Adding the 121 and the 72, 193. And then the radical terms are like, they both have the square root of 2 attached. Negative 66 and then minus 66 again would be minus 132 square roots of 2. Right? Minus 132 times the square root of 2. And there you go. And these don't go together, right? This is a constant term, not a radical, and this is a radical term. These do not go together. And then once again, you can test it out using a calculator, see if the expression in the beginning is the same as the expression at the end. But I leave that to you. Alright, so we have 193 minus 132 times the square root of 2. And that should be good. Wonderful. Alright, I got another one of these. Now again, you can use a special formula or just multiply like polynomials and combine like radicals at the end, like terms, and end up with the same thing. Alright, so here we have 9 minus 2 times the square root of 3 times, and then 9 plus 2 times the square root of 3. Now you may recall this. If you take a minus b times a plus b, you're getting a difference of squares, a squared minus b squared. So you could use that little formula. A here is the 9, and b here is the 2 times the square root of 3. So I'd end up with 9 squared minus, and then 2 times the square root of 3 squared. 9 squared is 81, minus, and then squaring this, you'd have 4 times the square root of 9. You'd have 4 times 3, which is 12. Then 81 minus 12 is 69. Alright, this should end up being 69. Well, that's one way to do it, right? This was the formula, right? The formula way. Or we could distribute the 9. Right, that'd be 81 plus 18 times the square root of 3, and then distribute the negative 2 root 3, giving me minus 18 times the square root of 3, and then minus, minus 12, right? 2 root 3 times 2 root 3 would be 4 times the square root of 9. 4 times 3, 4 times, which is 12. And you see how those middle two terms go away? Positive 18 root 3, negative 18 root 3, those go away, and I end up with just 81 minus 12 like I had over here, or 69. Right. So that's it. Very simple. Right. 69 is what we're going to enter. Okay, great. And then the last couple questions should be on, and I'm going to do exactly what I've been doing with these, radical expressions with multiple terms, is distributing. All right, lots of distributing, multiplying the way I would multiply polynomials. So let's do that again here. All right, so once again I have a radical expression with two terms times another radical expression with two terms. I'm going to do a lot of distributing. So I'll start with this 7 times the square root of 10, and we'll distribute to the other expression. Now 7 root 10 times 7 root 10, that'd be 49 times the square root of 100. All right, multiplying the non-radical factors and the radical factors. And we'll get to this. It's easy to simplify this, right? Square root of 100 is 10, so this will just be 490. Anyway, then 7 root 10 times positive 3 root 11. The 7 times 3 is 21. And square root of 10 times square root of 11 would be square root of 110. And that doesn't simplify any further, right? Because that's 2 times 5 times 11. There are no perfect squares that go into 110. Alright, so I'm done with the 7 root 10. Pardon me. Now I'm distributing the negative 6 root 11. All right. Negative 6 times the square root of 11 times 7 root 10 would be negative 42 times the square root of 110. And then negative 6 times the square root of 11 times positive 3 times the square root of 11 would be negative 18 times the square root of 11 squared, the square root of 121. Again, that's just 11. That's easy. All right, and then we simplify some stuff. Now, remember, 49. Now, the square root of 100 is 10. All right, this is just 10. So this is 490 here. Then these two middle terms go together. They're like radicals. They both have the square root of 110, so I can put those together. 21 minus 42 is negative 21, so I have minus 21 times the square root of 110. All right. And then, as I mentioned, square root of 121 is 11. 18 times 11 is 198, so this is minus 198 over here. And then I have these terms to combine, 490 and negative 198. That'd be 292. All right, 292. Yeah, 292, then minus 21 times the square root of 110. And once again, these don't go together because one's a non-radical term, the other's a radical term. So this is it. 29 minus 21 times the square root of 110. And once again, you can enter the original expression in your calculator, this one in the calculator, and see that they indeed give you the same value. Okay. All right, so let's enter that. Pardon me. So 292 minus 21 times the square root of 110, and make sure the 110 is all underneath the square root there. Great. All right, then I should have just one more of these. Once again, it's just like multiplying any polynomials, right? Take every term from one, distribute it to the terms from the other. And this one's even nicer because it's just a single term, cube root of 6, multiplied by two terms. So all I'm doing is just distributing the one term here. Yeah, so all I'm doing is distributing this cube root of 6. Now 5 times the cube root of 6 is exactly that, just 5 times the cube root of 6. Don't make that the cube root of 30, all right? Because one's a radical, the other's a non-radical factor. You don't multiply those together. But I can multiply the next ones, right? Plus the cube root of 6 times the cube root of 12 would be the cube root of 72. All right, cube root of 72. And let's try simplifying this. All right, now the cube root of 72 this is the cube root of 8 times the cube root of 9. All right, 8 times 9 is 72. All right. 8 is a perfect cube. 8 is 2 cubed. 9 is not. That's 3 squared. That's not a perfect cube. So this simplifies to 2 times the cube root of 9. All right. So that's what I'm going to replace that with. So we have 5 times the cube root of 6 plus, and then the cube root of 72 is 2 times the cube root of 9. And then these don't go together, right? Because they're not like radicals, right? They're both cube root terms, sure, but the radicands are different, right? 6 and 9. So this is as far as it goes, right? Do not combine these. And that's what I'll enter. Right, let's go back to the problem. We have 5 times the cube root of 6, then get out of there, and then plus 2 times the cube root of 9. Right, that was the cube root of 72, and that should be good. Wonderful. Alright, and that should be it for this version of this assignment. And again, as I said at the top of the video, please know that the questions I saw here in this video are probably not going to be the same questions you see when you do the assignment on your own. But the objectives are the same, the way you would go about doing them are the same, very, very similar. So hoping that watching me go through these 12 questions here help you out when you're working on the assignment on your own. And thank you very much for watching.